Hello everyone, this is Kinchal Parmar. Today we will discuss analog to digital converters. So let's start. Analog to digital converter. An analog to digital converter is a device that converts analog signal input into digital signal output. Basically, analog to digital converter is a device which converts analog information into its equivalent digital form. An analog to digital converter produces a digital output that proportional to the value of the input analog signal. Basically, analog digital converter produce digital output which is proportional to the value of analog input. Here we have a basic block diagram of analog to digital converter. We have a two input clock and analog input. Analog input is obviously input which is used to convert analog informations into digital form, and here clock is used for synchronization purpose, as if we have a more than one analog values for a conversion, then if we want to perform this conversion synchronized way, that means after one conversion we have another conversion, so we have to give this clock signal as a reference purpose. So using this clock we can perform this analog to digital conversion in a synchronous way. So here we have a two input analog input for a conversion in a digital form, and another is clock for synchronization purpose. Here we have a n bit digital output. This analog information can be converted into n bit digital output using this analog to digital converter. Now here n bit, that means we can convert analog information into 4-bit digital output, or says into 8-bit digital output, or says into 16-bit digital output, or whatever our requirements. According to that we can convert analog informations into n-bit digital form. So this is a basic idea about this analog to digital converter. The analog to digital converter converts an analog information into its equivalent digital form using following procedure. To convert analog information into digital form, we have a three procedure to follow. First, sampling; second, quantization; third, encoding. Sampling, quantization and encoding. These three are basically a method, or says a procedure, which can be used to convert analog information into digital form. Now what is sampling, quantization and encoding? So we'll discuss one by one in this session. Here, this analog to digital conversion, we have a analog information, then we use this analog information to first block, that is sampling, then another block, that is quantization, and the output of this quantization is given to the encoding block. So we have a digital information. Basically, sampling is a process to take a sample of analog information. Then quantization, that means in this block, this sampled value in a quantizations can be discriminated into a different label, and after labeling we can encode the information into digital form. So this is how, using three procedure, we can convert analog information into digital form. Let's discuss one by one what is sampling, quantization and encoding. First, sampling. The analog input signal, which is continuous function in a time, has to be held a constant for a short period of time, during which the analog to digital converter can convert the instantaneous value to its digital representation. This process is done by sampling and holding. As we know that analog is basically a continuous value, and for a digital form we have to convert this continuous value into a finite value, or says into discrete value. So using this sampling and holding function we can convert this. That means we take a sample, and for using this sampled value we can convert this continuous value into discrete value. Sampling is a process of measuring the amplitude of a continuous time signal at a discrete instant, convert the continuous signal into a discrete signal. So basically sampling is a process of measuring amplitude of a continuous time signal at a discrete instant and convert the continuous signal into discrete signal. Sampling takes the sample's voltage of a continuous varying analog signal and hold its value at a constant level for a specified minimum period of time. Sampling takes the sample voltage of continuously varying analog signal and hold its value at a constant level for a specified minimum period of time. Here we have a process of sampling. Here we have a one diagram of analog information in which we have a continuous data and which has a amplitude of this A and says positive A and negative A, and this continuous analog informations can be sampled or says can be converted into a few value by taking sampling. So this continuous analog informations is converted into the following form using this sampling block. So we can take a sample of at a particular instant of time. It says for a t1 duration we have a this amplitude, then t2 duration we have a this amplitude. So using this method, here we have a this duration, we have a this amplitude. For this duration, we have a this amplitude. For this duration, we have a this amplitude, and so on. So we have a basically finite value for a particular analog signal. So our analog signal after sampling is looks like this. Basically here we take a sample at a particular interval of time for a conversion into digital form. So here this is the diagram of one envelope signal which is converted into a sampled form. So this is a procedure of a sampling for a analog to digital conversion. Here we take a sample of a continuous analog signal at a particular instant of time. Then we have a quantization process. The digitization of analog signal involves the rounding of the values which are approximately equal to the analog values. As in a previous sampling process, we take a sample of a particular instant of time. Now we have a sampled value at a approximate voltage level. So here we in a quantization we convert or says we round off this value to the particular integer value for a conversion of a digital information. The method of sampling choose a few points on the analog signal and then these points are joined to the round off the value to the near stabilized value. Such a process is called as quantization. The quantizing of an analog signal is done by discretizing the signal with the number of quantization level. Quantization is representing the sampled value of the amplitude by a finite set of levels, which means converting continuous amplitude sample into a discrete time signal. Discrete time signal, that means we have a finite value. In a continuous we have a infinite value, but in a discrete time signal we have a discrete, that means a finite value. So quantization is a process of this converting continuous value into a nearby or discrete finite value. Quantization is the process of mapping continuous infinite value to a smaller set of discrete finite values. So here we have this table for a quantization process. Here we make a round of this approximate sampled analog value into a quantized value. For example, if we have a total 16 quantization level, we can convert the sampled value into a part by using this quantization level. So we make a horizontal part for this purpose. So we can make a 16 part or says 8 part according to our requirement. We generally make a part into 2 raised to power. So here we convert this sampled value into a nearby quantized value. Like for example, from 0 to 0 0.5 we consider a quantized value 0. Then for 0 0.5 to 1.5 we consider this number, or says we consider sampled value between this range is equal to 1. Then from 1.5 to 2.5 we convert this value into 2. So basically we make a margin of plus or minus 0.5 for any number. So we can convert this nearby value to its approximate integer value. Here integer value, that means we can convert this integer value into its binary equivalent form in a encoding format. So here we have a sampled value and quantized value from a range of plus or minus zero point 0.5. So zero point 0.5 to 1.5 we consider the whole the any number between this is equals to 1. For example, if we have a sampled value like 1.4, so we consider this 1.4 is equivalent to 1, and so on. Like for example, 1.5 to 2.5 we consider this as a 2, 2.5 to 3.5 we consider as a 3, then 3.5 to 4.5 we consider as a 4, and so on. So here generally upper bound 2.5 is approximately equal to 2. So after this says we can say that 2.51 to 3.5 we consider this as a 3. Basically 1.5 to 2.5 consider it as a 2, and 2.51 to 3.5 is equal to 3. So this is how we can convert sampled value into a equivalent quantized value. Here we have a graphical representation of this quantization process. What we do here, this sampled value is then given to a quantization block. So in this quantization block, we make a horizontal parts of this total sampled value, as here indicate as a 0, 1, 2, 3, 4. Here we make a part of this total analog signal into a 16 part. Basically here we use this sample value as we can first convert analog information into a sampled analog information. Then after sampled analog information we can give this information into quantization, and after quantization we have a analog informations. Like this we convert this sampled value into a parts, or says into a quantization level for a conversion of digital informations. So here we make a quantization level of total 16, 0 to 15, that means 16 value. So here we make a horizontal parts of this total quantized value, and then we can convert this information into digital. So here in a quantization we have a basically round off procedure between this intermediate values of any analog voltage. And how we can do this? So we here make a horizontal part, or says labeling. So using this we can convert the sampled value into a quantized value. Then next procedure is a encoding. Encoding is the process of converting quantized signal into a digital representation. After identifying the closest value, a numerical value is assigned to it and it is encoded in the form of a binary number. For each quantum, a unique digital code will be assigned, and after that the input signal is allocated with this digital code. If the number of quantization level is L, then the number of bits is NB is equals to log 2L. Like for example, if we have a total 16 quantization level, so log 2 16, basically we have a 16, 2 raised to 4 and log 2 to 1. So we have a NB is equals to 4. So for this quantization level of 16, we have to use 4 bit, and as we know that using 4 bit we make us we can represent 16 possible combinations. So basically in a 2 raised to power we have this bit. For example, if we have a total 8 quantization level, so we have to use 3 bit binary number. If we have a 4 quantization level, then we have to use 2 bit for a binary representation, or says to represent digital informations. What are the number of bits? So we can calculate the number of bits using this equation of this quantization level. Here we have a table for this encoded digital value, as we have a sampled value and we have a quantized value. So we have a sampled value, then we round off this into a quantized value, and after this quantized value we encode this information into digital form. Basically it's equivalent binary representation, or says how 0, so 0 0 0 1, that means 0 0 1. And why we use here 4 bit? Because here we have a total 16 quantized level, so or say 16 total values. So to represent this 16 value we have to use 4 bit. So here, that's why here we have a digital output in terms of 4 bit. So here this is how we can convert analog information into digital information using sampling, quantization and encoding. So here we have a quantized value and its equivalent digital informations, basically a binary representation of given decimal number. For 0 we have a 0 0 0, for 1 we have a 0 0 0 1, for 2 we have a 0 0 1 0, for 3 we have a 0 0 1 1, and so on. So this is how, using this three process, sampling, quantization and encoding, analog informations can be converted into digital information. So here total analog to digital conversion process. First we have an analog signal, then we give this information into sampling block. So after sampling block we have a sampled value at a finite duration of a time, or says at a particular interval of time. Then this sampled value is given to quantizing. So in quantizing value, we have a quantized signal. Basically, we make a horizontal part of this sampling and make a round off between this analog voltage. As we have a says here value like this, we make a first sample and we have a value over here like 1.4. Then here we have a value like 3.2. For example, if we have a value over here, this value is basically known as says 9.1. As we start over here, so we have a 0 value over here, then up to here we have a 7, and for this we have a 8. Okay, so here we consider this as a 9.1, this consider as a says 10.6, and this consider it as a says 15, or says 15.5. We have a value 15.4. Okay, so we have a basically sampled value at a 7, 9.1, 10.6. Then this sampled value can be converted into a stable, or says into integer value for conversion into digital information. So this 7.6 or whatever the value, we make this as a 8, Then 9.1, so we make this as a 9. 10.6, so we make this value as a 11. As here we have a this quantized value, so here we make a basically horizontal part. So basically this point has a value of 8, this point has a value of 9, this point has a value of 11. So this is how we convert this quantization level using this round off procedure to denotes a particular level of this sampled value. After this quantized signal, we give this quantized signal to a encoding block. So we have a encoding block, and this analog information, or says this quantized information, can be converted into its equivalent digital form. For example, if we have a 7 over here, so we convert this information into a digital form like 0 1 1 1 1, binary representation of 7. Then for example, we have a next number 9. So for 9 we use 1001. So this quantized value, approximate quantized value, or says rounded off quantized value, can be converted into its equivalent digital form by considering this sampled value, and after quantizing value into a particular finite number of values, or says at a discrete value, or says integer value, and this integer value can be converted into a binary representation, and we have a digital information. So this is how we can convert analog informations into a digital form using this sampling, quantizing and encoding. So in today's session, we discussed about analog to digital converter, basic architecture, basic block diagram, and a conversion process. In next session, we will discuss about various method of this analog to digital conversion. Thank you.